Hello, one. So in this video, I'll talk about angle sum identity for sine, but maybe we can apply that into difference as well. But let's go with the sum first, okay? So it's just sine of two angles, like sum of two angles, alpha and beta, let's assume, is equal to sine alpha times cosine beta, okay, plus sine beta times cosine alpha. So this is the identity that we are trying to, I guess, either prove or try. So either one is good to say, okay? So let's try to think about it. So, and if you are wondering why we are using this or why this is, I guess, what we are doing now. So because a lot of other identities, like the sum identities, like or difference of angles, like can be actually derived from this guy. So which is why it's really important for us to really understand this, for us to get the others as well easily. Okay, so it says again, alpha and beta is acute angle in our case. So the sum of those two. So we have sum of two acute angle, right? And then we usually use right triangles or the unit circle. But to make this like a proof, I will just use a right triangle. Okay, so let's go ahead and do that. So I'll make a triangle where I have alpha and beta as two angles, and sum of those two will be my one of the other angles. Okay, so let's think this is my right angle. Okay, so what I'm gonna do, I'm gonna add another segment so we can make some two different angles, alpha and beta. So let's say this is something like this. And what I will do, I will name this guy right here alpha, and I will name this guy as beta. So if you are remembering, like the angle, whenever you have a triangle, let's say, maybe I should have labeled those. So let's call this is A, B, C, and D. So in the triangle ACB or ACD actually, this triangle, I have alpha and beta as two interior angles, and I have one exterior in that triangle. Like if this is my third interior, so this is gonna be my exterior angle of alpha and beta. So if you remember the exterior angle theorem, so the sum of those two is actually this guy. So I will go ahead and write this right here. And if you don't remember, you can just say this is let's say something else like theta, alpha, beta, and theta is add up to 180, and theta plus this is also 180. Since this angle with the other two angles as well as this angle make a supplement each other, so which is why this has to be sum of the other two, which is actually one of the ways to prove this identity, this relation. Okay, but anyway, so this is just a like one of the facts from geometry, I guess you should remember. And now this is a good picture, but how this is going to be useful, right? So I like to use this sine of alpha plus beta. So, you know, if I want to take the sine, so it's basically this guy divided by this, but I don't know any of these. To make our life a bit less miserable, I will actually name this AD as 1. Okay, so why? Because when you take the sine of alpha plus beta, it will be just a segment. So which is why it's better to use that way. So let's go ahead and write that. So if I take this sine alpha plus beta, you know, sine of something was the opposite over the hypotenuse. So in this ABD, so the opposite side for this angle is AB. So I'll go with AB over hypotenuse. Hypotenuse is 1, so which is why I just chose this one, so we can actually have a bit less complicated expression. So that's AB. So the AB is actually sine of alpha plus beta. So let's go ahead and write it. So sine of alpha plus beta. So basically this segment. Okay. But this is not really that useful yet because we never use alpha and beta separately because we have these we like to have. Maybe I should have some another right angles to our play. Okay, so to do so, I'll just take this point D and drop the altitude from that point to AC so that I can use sine cosine in this triangle and this triangle. So if I take the, let's call this is H. So if I take this triangle, right? And if I like to get AH, I like to use the cosine because AH is my adjacent side and the hypotenuse is 1, so which is actually good to use. So let's go ahead and do that. So cosine alpha is AH over 1, which is just AH. So this is a cosine alpha, this piece. Okay. And I just like to know the HC, but it doesn't look like we can because we don't know this guy. We don't know this guy either. But maybe we can try finding this one, right? So this is my opposite side in terms of alpha, right? So, and then this is my hypotenuse. Maybe I can use this sine, right? So let's go ahead and use this sine alpha in this triangle as well. So this sine alpha is equal to, this was D, HD over hypotenuse, which is 1. So the HD is sine alpha. So this is something useful. So this is sine alpha for this segment or this leg. Okay, so everything looks okay so far, but I just don't have this HC. So let's go ahead and find it as well based on maybe this angle. So I know this segment, this leg is sine alpha. Maybe I can use the tangent of this beta because that will tell us something about HC. So let's go ahead and do that. So if I go with the tangent beta, that would be equal to opposite to the angle, which is sine alpha over the adjacent, which is HC. So if I just swap these guys, so the HC is gonna be sine alpha over tangent beta. Okay, maybe we can simplify this a bit, but let me write it for now. So that will be equal to sine alpha over tangent beta. So if you are wondering how these will actually helpful to get this guy, right? So you will see soon. So, we have now in the larger triangle, I have this leg and then I have the hypotenuse. Maybe it's time for us to use the another trig identity, which is I'm going to use the sine of this beta because I know the opposite side, I know the hypotenuse. Let's go ahead and use that. In the triangle ABCD, ABC. Okay, if I use this sine beta, it will be opposite to AB and hypotenuse will be AC. Okay, so the AB is sine alpha plus beta. Okay, so over, and the hypotenuse is sum of two things, which is I like to write it both. So cosine alpha is just the AH part plus this sine alpha over tangent beta. Okay, so we have something, but it doesn't look like really nicer. If you don't really see it, maybe we can just write this guy as over 1. So I have a fraction, I have another fraction, so I can do cross multiplication. So let's do this. Sine beta times this whole denominator. So let's go ahead and do that. And equals sine alpha plus beta times 1. So let's go with those first. Sine alpha plus beta is equal to sine beta times cosine alpha plus sine alpha over tangent beta. Okay, so if you expand this, I guess that will be useful. So sine beta times cosine alpha. So sine beta times cosine alpha plus, so I will multiply this by this fraction, but tangent is something we don't need because we have to find something like sine and cosine. Maybe I should change this as well. So this guy, I'll just do this sine word right there, is equal to like sine alpha over, so this is tangent beta, which means sine beta over cosine beta, right? Sine, if you divide sine by this fraction, so you can just take this as sine over 1, and this is sine b over cosine b. So the first fraction is sine alpha over 1, and the second fraction will be like flip, so which will be cosine beta over sine beta. Okay, so this is something we want to keep in mind because this is what I'm going to use. So this is just the this fraction. Why this is big deal? As I said, I need sine and cosine, not tangent. So now if I multiply sine beta by this fraction, basically I will multiply that sine by sine beta by this one. So if you multiply this by sine beta, you know, this sine beta will cancel the numerator sine beta. So I'm not sure if you see that. So if I just go with that, so sine beta times, and this whole fraction was equal to this. So let me write this, sine alpha times cosine beta over sine beta. So these guys will cancel. And we have actually exactly what we were looking for, because sine alpha plus beta, which is the left side of the equation, equals sine beta times cosine alpha. So sine beta cosine alpha is this part, plus sine alpha cosine beta, sine alpha cosine beta. So I can just take this guy and write it first and then this product after, which is exactly the same thing as this guy. So now our proof is done. So I hope that makes sense. So this is, I guess, one of our most important identities. So if you don't really get it, I will say maybe start from the beginning and slowly digest every single step and don't move on unless you're convinced. And as soon as you really understand the process, go ahead and try this on your own and see if you can get the same result, okay? And that is what I highly recommend you to do. So that's the first thing. The second thing, by using this, and some of the other like basic identities, can you try to find the sine of alpha minus beta? So to give you a hint, so you can just switch this beta with minus version of this guy. So in all this identity, because if this is identity, it should satisfy everything that you choose for alpha and beta. So choose this as minus version and plug it right here and see what you have. And that will give you another identity, okay? So I hope that makes sense, and I'll see you in the next video.